When will the tortoise and the rat pass each other? So what I'm going to do is go back to my diagram and realize that my tortoise has passed my rat. But where did that occur? It looks like it occurred right about there, because I don't see two different dots. I see one dot occurring at that spot. Kind of looks like it's about 73 seconds. But was it actually 73 seconds? Was it 72 seconds? Was it somewhere in between? I don't know that for sure. I have an idea where it occurs. And I'll show you a way to use this technology to get you the correct answer. But for now, I just know that at some point, the tortoise's distance, t of x, and the rat's distance, r of x, have to equal each other because that's when they pass. I think substitution is the way to go. What's another way to write t of x? Another way of writing t of x would be to write the actual equation, 0.75x plus 1,000. Let me move this over a little bit more. Which is in feet from the starting line, is going to eventually have to equal negative 2x plus 1,200 to them. Now it's a case of solving this problem. If it was me, I'd probably move the 2x over to the other side. Come up with 2.75x plus 1,000 equals 1,200. I would subtract 1,000 from both sides. I'd come up with 2.75x equals 200. And then it's just a case of me taking 2.75x equaling to 200 and dividing by 2.75 to both sides. And I will find out that that happens to be x equals 72.72 repeating seconds. If you want a fraction, it's technically 811ths. I said it was close to 73 seconds. I didn't say it was 73 seconds. So in this case, 72.72 seconds. But that only answers when will the tortoise and rat pass each other. It does not actually answer the question how far they will be from the starting line. That's where we go back and we plug in this number, 72.72 repeating. Now this is why I would recommend using the fraction. If you were wondering why I wrote down the fraction, this is exact. Okay? And so when I plug it in, and especially since we have calculators that do fractions, and I plug it in, I get 1,000. It's not going to make a difference if I put it into the tortoise equation, because if I put it into the rat equation, remember, this is the exact moment they're both at the same distance, okay? You're going to find out that they're both were 1,054.54 repeating feet away from the starting line. I'm going to do the same thing with the hare and the rat, and I'm going to do the same thing with the tortoise and the hare. So literally practice, practice, practice. Before I do that, let's go to the hare and rat. Let's just take a guess what that might be. Hare and the rat. Here is the rat graph. Here's the hare graph. It looks like roughly, I don't know, I'd say maybe about that time. 150 seconds. Let's see how accurate we are with this. So let's go through the steps again. I'm not going to write out all the steps as I did the first one, but I think it's important to say h of x is going to equal r of x, because that's what tells you, hey, 6x has to equal negative 2x plus 1,200. We'll use all our prior skills. You know that I'm going to move the 2x over to the other side. And you know that I'm going to divide both sides by 8, and in this case, it actually is 150 seconds when they will pass each other. And then if I want to figure out exactly where that occurs, I can either do h of 150 or I can do r of 150. Probably do h of 150 because 6 times 150 is pretty easy to do. That's 900 feet. If I really want to do negative 2 times 150 and then add on 1200, well, that's negative 300 plus 1200, which is still 900 feet. So there you go. I not only answered when it occurred, I also told you where it occurred. Okay, we already know that the hare is going to win this race. So that means the tortoise is going to get passed by the hare at some point. And it looks like it's going to occur right there. I might be slightly off by a second, but it's roughly around the 192nd mark. Let's go see how accurate I actually am on this. If we set t of x equal to h of x, or we say literally 0.75x plus 1,000 is equal to 6x, I'd probably move the 0.75 over to the other side, and I come up with 5.25x. And when I would divide both sides by 5.25, you're going to come up with x equals 190.476 seconds. If you're looking for a friendly fraction, that works out to be 4,000 divided by 21. So when I said roughly 190, not a bad guess, but it wasn't exact. And one last time, I could put it into the tortoise equation, and I'm going to just use the fractions only because it's exact. And I could have gone 0.75 times 4,000 over 21 plus 1,000, or I could have gone h is equal to 4,000 over 21 and just simply gone 6 times 4,000 over 21. But in both cases, they're both going to come up with something that is close to 1,142.857 feet. This is 190 seconds. You can see that's what the graph says, 190 seconds. But I also want you to pay attention going across this way. That if you go across this way, you'll see that the height is supposed to be very close to our 1,142 feet. That's it. Okay, so now, before I go any further, our next problem is going to be when does the hare cross the finish line and all that. To be honest, it's not going to be that different. But what I'd like to show you right now in GeoGebra is how to get these points without you having to do substitution. So before I do that, let me just go back to this page and make sure that you understand that all three of these methods were always substitution, so that you have something to refer to when it says, hey, I'm supposed to do substitution, look here. Can you do something similar? Okay. I'm going to show you now how easy it is to do graphing and finding the intersection points. You just have to know where to look for the command. And in this case, the command is right here. Well, it's actually click on the icon, go down to intersect, and click on that. Did you find it? Do you do it one more time? Click on the second icon, go down, look at the point, look for intersection or intersect. What you do is then you tell the computer, please tell me, or you tell the computer what two graphs you want to intersect. If you put your mouse over one of the graphs, it should change it to the hand. Click on it. It gets highlighted. Move your mouse cursor to another line. The hand pops up. Click on that, and it will even give you the point A right there. But now I want you to even do something more special. I don't want it just to be A. And yes, here's the point of intersection. I want that point to actually be on the graph. Here's how you do it. If you want, you can try right-clicking the point. Basically, I need you to be getting this little sidebar up in a moment. Okay? Either click on the, by the way, you may have to click on the arrow first. Click on the point, or click on the three dots of the point, and you're going to get settings. And what you want are the settings over here. And over here, it's going to give you options. You want to see the point? It's checkmarked. You want to see a label for the point? It's checkmark. But I don't want to see the name A. I want to see the actual value. And then, if you feel that you need to move it, you can move it around to different locations. I need you to do this with a lot more points. You've got 2 more chances to practice. I will demonstrate one more time, but I would like you to be able to do the third one on your own. Go to where the point is. If it's not already selected as intersect, select intersect. Find a graph, in this case the tortoise graph. This time I'm going to choose the hair graph. I've got point B. Yes, this is exactly the coordinates I'm looking for. This is the amount of time. This is the distance, just like I said it was on the paper. But what I would prefer is to have that actually be coordinates. Click here on the little 3 dots and choose settings. Over here on the side, this should pop up. Look under show label. It should be check marked. Change it to value, and there you go. Try it with the third one. This is solving by graphing. Doing it here isn't going to help you look at your notes, so I'm going to ask you to go back to your page right now, and we're just going to go to the third page, and we're going to mark up these points. I will give you the coordinates one more time, but actually, you know what they are. This coordinate here works out to be 72.72 repeating, comma, 1054.54 repeating. This point here works out to be 190.476 and 1142.857, and again, I've rounded to 3 decimal places. You don't have to get that fussy. It'll be good. Your last point over here ended up being 150, comma, 900. There's a few things I'm going to do because, well, I can. Because of the notes, I think it would be smart to say that this is the h of x graph. You might want to label that. That's your hair graph. We know that the tortoise has started at 1,000 feet from the starting line. So this has got to be the tortoise graph. And the negative slope along with the starting value of 1,200, this is the, oops, wrong one. This is the r of x graph, the rat graph. And the one on top, well, that's your finishing line. That's f of x. Let's go back to the second page. And now I'm going to ask you all about the finishing touches, aka who finishes first? Well, here you go. Let's finish the race. And you'll see, going back to using slow motion instant replay, rewind a little bit, the hair crosses the finish line first. The hair, however, doesn't stop. It's like a bunny, keeps on going and going and going. Finally, the tortoise crosses, and you'll notice it's taken quite a bit of time for the tortoise to cross. We'll have to figure out what's going on. And if you go far enough, I guess you could say the rat has its own line to cross, but in this case it crosses the starting line. You know what? I could intersect and find these points. But that would defeat what I'm trying to teach right now for substitution, so guess what? We're going to do it first by substitution. And then we will go find it by the graph. So who came first? All right. We had the hare. Now this question actually reads the following. If you read it carefully, it says, when the first animal crosses the finish line, what was the order at that moment? So I guess I should be clear here. I'm asking you what happened, where is everybody at that exact moment in time? And so that is the hare, the tortoise, and the rat. And so that's what we'll put here. Hare, tortoise, rat. Here we go. At what time does the winner, which is the hare, cross the finish line? Well, this could be set up exactly the same way as before. H of x equals f of x. Literally, when is the hare's feet position exactly at the finish line's feet position? When does 6x equal 1320? Yeah, that's it. That really is the whole setup. And in this case, it occurs at 220 seconds. And then simply, I use substitution. So when you get to your substitution problems, I'm probably choosing substitution as the method because it should actually go pretty quick, if you understand what I'm looking for. Now I'm going to do this time, I am going to actually go back and kind of bounce and follow the instructions. It says identify and label the point on the first graph. Well, let's go do it on the computer system first. So back to the computer system, and let's go find where this intersects. Well, in this case, it would be this graph. And I think I want that point right there. So there you go, intersect. It's intersect, click, click. Come on, there we go. Feel free to show the coordinates. Feel free to move the coordinates. Make it easy for yourself. Okay. And then let's go back to the document and actually fill in those coordinates on the paper so that you have something that right now that you can actually look at, which means back to this point here, and that was 220, 1320. I always like when they say, you know, how much did you beat them by? They aren't specific. Because there's two ways you could describe it. Did you beat them by distance? Like, how far did you beat them distance-wise? Or how far did you beat them time-wise? They're different. We're going to find both. Okay? And it's actually going to be pretty easy. And I'll explain why it's pretty easy. We already know that at 220 seconds, it's 1,320 feet because we just figured that out right from here. All we need to do is figure out where the tortoise is at 220 feet. And we do that by using our function notation and plugging in 220. You could almost say you're substituting, which actually that's exactly what you're doing, into that. Add 1,000 and realize that the tortoise would be at 1,165 feet from the starting line. So if I wanted to know what the distance is, it would make sense to take 1,320, subtract 1,165, and find out that the tortoise the hare beat the tortoise by 155 feet. That really wasn't that bad. That's the difference. just like, hey, what's going to be the difference in prices between, let's say, this and this at a certain number of visits? Okay. I'm also going to ask you, literally, what was the time difference? And really, the reason I'm doing this one is so we can get just a little bit more practice of doing exactly what we did up here. AKA, let's substitute where we've set T of x equal to the finish line. We go 0.75x plus 1,000. You make that equal to 1320. Yes, you can move the 1,000 over. Come up with 320. Yes, you can divide both sides by 0.75. Come up with 426.6 seconds. As a fraction, that works out to be 1,280 over 3. So I'm just going to temporarily sneak back over here. This is what we just found. It takes this long for the tortoise to finally cross the line. And what I want to know is I want to know the distance between this dot and that dot compared to the last question where I wanted to know the distance between the hare's 1320 and the tortoise's that. So this was a distance difference. This is going to be a time difference. And so, to do that, I just take the 426.6 repeating. I'll subtract 220. And what you realize is, oh my goodness, it seemed pretty close, 155 feet difference, but the tortoise is moving so slow that the tortoise is technically 206.6 seconds behind. And since there's 60 seconds in a minute, we're talking 3 minutes, 26.6 seconds. It is one very slow-moving tortoise. Let's go find this intersection point. Let's go find the coordinates so you can see that I'm really enforcing this. Here we go. Intersect. Graph. Graph. There's E. Change the coordinate. I find this to be the easiest way down here. Click on settings. There's the value, just like we said it was, 426 2/3. But I'm going to put it up here, value. Got to be able to see it, so let me change it to a cursor, and so I can drag this down. Oh, now I can see it. All right. So one last new skill. I want to cut this into my Google Doc. So you're going to have to learn, go find the menu, the 3 little bars. Find under File. There should be under Save, specifically it says Export Image. This window pops up, and then you should be able to hit Copy to Clipboard. Okay. Now what you need to do is you need to go to your Google Drive or Google Doc or whatever you're going to do. So let's go do that right now. So go into a Google Doc. If you want to do Drive or just docs.google. I'm just going to create a quick one right now. Hit plus. And you should be able to just right-click and hit paste. Oh, in my case, I use Firefox. You might be able to do it directly that way. There we go. And that's how you're going to get your graph into your document.